Hello students, this video is for class 8th, chapter 14, that is some natural phenomena. First of all, we should have an idea that this chapter belongs to your physics, and let's start this chapter. So first of all, we have to understand what is the meaning of charge, right? So we have to understand charge is basically it is nothing but a sort of entity defined on on their nature, right? So if we have to consider the structure of an atom, basically we know that either we have three type of subatomic particles, either like it can be positive, negative, or not having any sort of charge on them. So if you go to the center of the atom, that is basically called as the nucleons. There you have protons which are positively charged, and neutrons which are having no charge on them. So these two are held by the nuclear forces, which are basically charge independent, and electrons are the negatively charged bodies which revolve around the new central positive nucleus in a well-defined orbit, you can say. So the force that is responsible for holding the electrons and the neutrons together is called as electrostatic force. So the first thing that we have is the law of conservation of energy, which states like the entire electrical energy or sort of any sort of energy remains conserved in our system. That is, the value throughout the universe remains constant. Only it is something like that you have to understand. Energy can be transformed from one form to the another. Now, for testing of charge, what you have to understand is like. We know from the prior classes that there are two type of charges. First is either they can be your positive or your negative, and many day-to-day life examples you would have seen, like when you are rubbing a comb on your head and you are bringing them near to your pieces of paper, they might get attracted. Or sometimes you would have feel like when you're bringing your hand near to a TV screen, that time also you might see there's a sort of erection in your hairs, right? So what we can understand basically, like basic idea that we have about charges is the like charges they repel each other, and the unlike charges uh, they attract each other, right? Now, basically to find out for finding out the charge on any body, we have different type of methods. Those methods are like by induction, friction, or by conduction. So induction is something like when a charged body is brought to a body which is not having any charge on them, then the ionization sort of occurs. That is, the segregation of positive and negative charges occur. But you have to be careful that there should not be any contact between the two bodies, that is the charged and the uncharged one. So this type of charging is called as the charging by induction. And basically, like if you are bringing a positive charged body to a body which is not having any charge, the body will get negative charge, and the vice versa. Then charging by friction is somewhat different in terms, if you have to consider it with respect to induction. Basically, what we have, there is a physical touch required, basically rubbing of things. For example, if we have ebonite rod and we are rubbing it on a woolen cloth, then we might see some charges being developed on both of them, right? Now, charging by conduction is again simple, that we can understand, is somewhat refers to the being the two bodies physically touching each other, and it's somewhat basically used in terms of, you can say, conductors only. Now, gold leaf electroscope is a device basically that you have to understand, that is used for finding out whether a body is having a charge on it or not. And if so, like if the answer is yes, that is, the body is having a charge on it, then for finding out the nature of charge, whether the body is positively charged or negatively charged, for that thing we are using gold leaf electroscope. Now, flow of charges, we have to understand, we know that there are two types of bodies. We have classified them, either the bodies or the objects can be in conductors or insulators. Conductors are something that allow the flow of charges, or you can say electrons, through them, and insulators are the one that are completely opposite. And electric current is something that we have seen in previous classes also, is nothing but the flow of charges, right? Now, in our book, basically we have an experiment of what Mr. Benjamin Franklin did in the 18th century, and he basically made up a kite which was made up of silk, and he used a metallic wire which was tied to a very big key at the end. And when he was flying in a cloudy weather, and it started raining, and after a while he also got some shocks also, and he could see some sparks at the end of it. Now, lightning conductor, that you have to understand, is something which is used protection of very high rise buildings. And what concept that we have is like, if we have to understand, the clouds basically gets ionized, that is, segregation of charges occur. The negative charge is at the lower end and the positive charge, being lighter, is found at the upper end. Since during a rainy weather or in a valleys, when the clouds get accumulated and they start rubbing each other, then the electric discharge occurs. And basically, this electrical discharge, that is called as lightning, is accompanied by thunder, and which might cause severe damage to the buildings. So for protection of the building, of the high rise buildings, from this electrical discharge, what we have is a basically a rod like structure placed at the top of these buildings, which is connected to a copper plate which has been buried deep inside the ground. And what happens is like, the charges from the cloud, they flow through this hook like structure, they're passing through the wire and finally reach to the ground. So there are certain precautions that should be followed during lightning. There that are something like, whenever you see a lightning, try to go indoors. So like, if you are traveling in a car, then don't try to come outside, because as a whole your body is being protected by the metallic layer that you have. If in a particular area there are tall buildings, then the probability of those areas being getting struck by lightning is very high. So right, if you are sitting in an if you are if you found yourself being stuck in an open ground, then try to reduce your height by sitting in a posture, by like joining your knees and putting your heads on the head on your head on the top of your head, right? And like, when it's raining, don't try to go near to the water puddles. So try to remain dry as much as possible. And like, if you are inside the house, first of all, disconnect the electrical appliances and do not don't touch them basically. And last topic that we have for this chapter is basically your earthquake. And earthquake is nothing but, you can say, earth structure is basically divided into three layers, that is the crust, mantle and core. Crust being the outermost part, is having basically the land masses are divided into several plates called as tectonic plates. And these tectonic plates are responsible under the continuous motions, and sometimes when they get stuck with each other, or they have a flip sort of movement, then large shock waves are produced, which ultimately result in tremors or earthquakes, right? So as we said, crust contains your tectonic plates. Basically, there are seven tectonic plates. Then mantle, which is having a depth of only 40 kilometer. And then we have what you call as your mantle is something which accounts for more than 85% of the earth's weight, being the largest layer. And the last one is the core, which is basically a liquid in nature. And what liquid, by liquid what I mean to say is, like, because of high pressure and temperature, metals which are found in the core are basically in the liquefied form. So as we discussed about the earthquakes, basically we understood, like, when the tectonic plates which are continuously moving, whether they might be a continental tectonic plate or you can say oceanic plate, they get stuck with each other. Then due to friction, a large amount of heat is being generated, and along with that, some certain shock waves are being produced, which traverse in all the directions. So the point where actually they get rubbed with each other is called a seismic focus. And if you come on the top of the ground exactly above seismic focus, that point is called as your epicenter. Now we have a device that is called as seismograph, which runs 24/7 in the various meteorological labs. And the basic purpose for this is to measure tremors or earthquakes, right? And the scale that we use for measuring, the seismograph being a device, it uses a particular scale that is called as Richter scale. And on the as far as the magnitude is concerned of Richter scale, anything below 4.3, you can say, is like a moderate intensity, that is okay, acceptable. But if it crosses the level of 6.3 on Richter scale, then that can be classified as a severe earthquake, which might result in heavy losses of life and property. Now, certain precautions that should be followed for during the course of earthquake is like, if you're inside a building, try to go under the table or go near the pillars where you have concrete, this iron pillars. Don't use elevators for coming outside, you might get stuck over there. Don't be near the windows or doors, because they might get cracked up, or you might get injured because of the glasses and all. If your gas is turned on, just try to turn off that gas, might result in severe fire. And you should always have your phone numbers handy, some severe, like several emergency numbers. And when the first of all is like when you are living in an area which is earthquake prone, the construction of buildings should be done in a way which are resistant to the effect of earthquake. And lastly is like if you are driving a car, you just try to come outside the car and stand in an open place. So that's it from this chapter, guys. Thank you, and see you for the again for the next video.